When transitioning from polyvinyl chloride, or PVC, conduit to rigid metal conduit, known as RMC, it is crucial to understand the requirements for grounding and bonding to ensure electrical safety. The grounding conductor must be bonded to the RMC conduit. RMC is a more effective conductor than PVC, offering a superior path for grounding current. National Electrical Code Section 250.110 mandates that all metal raceways, cables, and enclosures used as electrical conductors must be grounded. The aim is to provide a low-resistance pathway for fault current to return to the source, thereby minimizing the risk of electrical shock and fire hazards. The grounding conductor is typically an uninsulated copper wire installed within the raceway or conduit. When transitioning from PVC to RMC, it is essential to bond the grounding conductor to the RMC. This can be achieved through various approved methods, such as utilizing a grounding bushing. It is not advisable to run the grounding conductor through the RMC without bonding it, as this practice can create a potentially dangerous situation. Grounding and bonding are fundamental concepts in electrical engineering, and adhering to the National Electrical Code, known as NEC, guidelines is imperative for ensuring safety and compliance. Grounding refers to creating an intentional low impedance path to the earth, while bonding involves connecting conductive parts to establish electrical continuity and conductivity. In the context of transitioning from PVC to RMC, bonding the grounding conductor to the RMC ensures that any fault current will have a safe and effective path to ground. This is crucial for the proper operation of overcurrent protection devices, such as circuit breakers and fuses, which are designed to interrupt the flow of current in the event of a fault. There are several methods for bonding the grounding conductor to the RMC conduit. One common approach is to use a grounding bushing, which is a fitting installed on the end of the conduit that provides a connection point for the grounding conductor. The grounding bushing is typically made of metal and has a set screw or other means of securing the grounding conductor. Another method is to use a grounding lock nut, which is a type of lock nut that has a built-in grounding lug. The grounding lock nut is installed on the conduit in the same way as a standard lock nut, and the grounding conductor is connected to the grounding lug. It is important to select a bonding method that is appropriate for the size and type of conduit being used. The bonding method must also be listed and labeled for grounding purposes. In addition to bonding the grounding conductor to the RMC conduit, it is also important to ensure that the RMC conduit is properly grounded. This can be done by connecting the RMC conduit to the building grounding electrode system. The building grounding electrode system typically consists of a ground rod, ground plate, or other approved grounding electrode. The connection between the RMC conduit and the building grounding electrode system must be made with a grounding conductor that is sized according to the National Electrical Code, or NEC, Table 250.122. It is also important to ensure that all metal boxes, enclosures, and equipment connected to the RMC conduit are properly grounded. This can be done by connecting a grounding conductor from the metal box, enclosure, or equipment to the RMC conduit or to the building grounding electrode system. Grounding and bonding are essential for electrical safety. By following the National Electrical Code, or NEC, guidelines for grounding and bonding, you can help to ensure that electrical systems are safe and reliable. Now to go into more detail on the specific code sections. National Electrical Code, or NEC, Section 250.4 covers the general requirements for grounding and bonding. It emphasizes the importance of creating a low impedance path for fault current and ensuring the electrical continuity of all metal parts of the electrical system. National Electrical Code, or NEC, Section 250.110 specifically addresses the grounding of metal enclosures, including raceways such as RMC. It requires that metal raceways be grounded to the equipment grounding conductor, which is the conductor that connects the metal parts of the electrical system to the grounding electrode system. National Electrical Code, or NEC, Section 250.118 lists the types of equipment grounding conductors that are permitted to be used. These include copper, aluminum, and steel conductors. The equipment grounding conductor can be a wire, a busbar, or a metal raceway. National Electrical Code, or NEC, Section 250.122 provides the requirements for sizing the equipment grounding conductor. It specifies that the size of the equipment grounding conductor must be based on the size of the overcurrent protection device protecting the circuit. National Electrical Code, or NEC, Section 300.10 addresses the continuity of metal raceways. It requires that metal raceways be mechanically and electrically continuous throughout their entire length. This means that the raceways must be properly joined together and that there must be a continuous electrical path from one end of the raceway to the other. To reiterate some key points, firstly, always consult the latest edition of the National Electrical Code, or NEC, for the most up-to-date requirements and guidelines. Secondly, ensure that all grounding and bonding connections are made in accordance with the National Electrical Code, or NEC, and that they are properly tightened and secured. Thirdly, use only listed and labeled grounding and bonding products that are appropriate for the application. Fourthly, when transitioning from PVC to RMC, always bond the grounding conductor to the RMC conduit using an approved method. Fifthly, ensure that the RMC conduit is properly grounded to the building grounding electrode system. Sixthly, ground all metal boxes, enclosures, and equipment connected to the RMC conduit. Seventhly, never run the grounding conductor through the RMC conduit without bonding it. Eighthly, understand that grounding and bonding are essential for electrical safety and that following the National Electrical Code, or NEC, guidelines is critical for ensuring a safe and reliable electrical system. Proper grounding and bonding are not just about meeting code requirements. They are about protecting people and property from the hazards of electricity. By understanding the principles of grounding and bonding and following the National Electrical Code, or NEC, guidelines, electrical professionals can help to ensure that electrical systems are safe and reliable. Consider a scenario where a fault occurs in a piece of equipment connected to an electrical circuit that includes a transition from PVC to RMC conduit. If the grounding conductor is not properly bonded to the RMC, the fault current may not have a low impedance path to return to the source. This can result in a voltage buildup on the metal parts of the equipment, which can create a shock hazard. In addition, the fault current may not be high enough to trip the overcurrent protection device, which can lead to a fire. However, if the grounding conductor is properly bonded to the RMC, the fault current will have a low impedance path to return to the source. This will prevent a voltage buildup on the metal parts of the equipment and will ensure that the overcurrent protection device trips quickly, protecting people and property from the hazards of electricity. Remember, electrical work should only be performed by qualified and licensed electricians who have the knowledge, skills, and experience to perform the work safely and in accordance with all applicable codes and regulations. Improper electrical work can be dangerous and can result in serious injury or death. In addition to the technical aspects of grounding and bonding, it is also important to consider the human element. Electrical safety is everyone's responsibility, and it is important to be aware of the hazards of electricity and to take steps to protect yourself and others. This includes following safe work practices, using appropriate personal protective equipment, and never working on electrical equipment that is energized.